Welcome back, everybody. So I wanted to first talk about the evaluation of the course, and then we'll move over to the quiz. Wow, we've done so many things. There you go. All right. So thank you for filling the course evaluation. It's really very, very important because we keep improving things and try to consider the feedback every time. So first, it's very I'm very touched by all these numbers. So thank you very much for that. I'm super happy that you appreciated the lectures and that you understood what I've been telling you during all these weeks. The TAs also did a great job. So thank you to the whole team. Maybe you can applaud. We can applaud the TAs also if they are not here today. One of my favorite questions is 8.2 here, which is if you're able to explain the most important material to younger students, because again, the best way to learn is to teach. If you actually can explain things, then it means you understand the material. And trying to explain and then noticing that you can't explain because you're missing something, that is how you spot what you're still missing. So this is really great to do that. And you can do it with each other. All right, and so that's the level of satisfaction. So again, that's really, really nice. In comparison to the courses, so yes, these two, so 18.1, 18.2, the goal is to be in the middle. That's in terms of difficulty of the lecture and workload compared to the number of credits. So we want to be in the middle. And then the last one is the inspiration. So there are also comments that you wrote that are also super helpful. One of the comments that I found interesting is a suggestion to reorganize the order of the in which the sections are done, because there was a lot of the complex parts at the end, and the beginning of the semester was easier. And I think that there might be a way to do this, because it might be that there are dependencies that would allow us to do that. Like, for example, the probabilistic part may be a bit earlier, the evaluation can be a bit later. So I'll see if I can reshuffle things a little bit around to have more balance during the semester. Also, it seems that the fact that the lecture is offered in the lecture hall, but also on Zoom, also as recording, is appreciated. So I plan to continue to do it this way. If it supports you in your learning. So this is great to hear. All right, now let's proceed to the quiz. Prepare to the exam. All right. And also thank you for the very, very nice word that some of you left in the comments. That really means a lot to teachers. So here's how it works. Who knows Eiskage 100? Some of you. So it's a game on television where there are plenty of people just like you in the audience who have to answer questions, multiple choice questions. And the goal is to have the longest streak. So you have to not be eliminated. As soon as you get a question wrong, then you're no longer running for the longest streak. But in our case, I still let you participate. So even if you sat down, you can still continue to answer questions. The TA team will also act as the candidate in the TV show. So they will also answer questions. If you have an element chat open on the phone, you can just, for archiving purposes, put your question in there, because I have to time the moment where you give your answer with the time that I lock the answer on your side. So, but we'll manage to do this. So yes, you can talk with each other, of course, to come up with your answer, the TA answer. So the first thing that we'll do is I will ask to everybody who wants to participate. If you don't want to participate, that's fine too. But if you want to participate, you can stand up right now. On Zoom, you can raise your hands. You can click on the button to raise your hands if you want to participate. So do we have people on Zoom who are participating? right? So I'll take the raised hands as standing up, equivalent to standing up in the lecture hall, right? So all raise your hands, everybody who wants to participate. And I have a few sweets for the winners. Of course, if you're in the lecture hall, you can have them right away. If you're on Zoom, then you'll have to get them in our building. So I'm going to ask questions. It's based on trust. I mean, the stakes are not super high, so I trust you when you get one wrong that you just sit down, but you can continue to answer question. Or on Zoom, you would lower your hands. And so we'll see if the longest, the student who holds for the longest will beat the TAs. So we'll see. Okay. So let's start then. So maybe I'll go random, or let's start with this. Then I'll start putting a time cap, and then we'll shorten the time every time. So how does the number of terms grow with the number of documents or tokens? It's the same thing as I said, that's what I put a T, in practice. Is it hyperbolically, logarithmically, square rootly, or linearly? I'm giving you enough time to put your answers in. Does anybody have any difficulty with the clicker? All working? Any technical issues? None? Nobody? Okay. 28, 29. Okay, and I'm going to stop here. All right. Oh, 30. Very good. So now I'm going to close, and then immediately after I have closed, you can give your answer, right? And did you put it also in the element chat? Yeah, that was the feedback. Unless, okay, let's do a poll. Who trusts the TAs? Okay, then that's good. So you have a majority. All right. Wait, close. Okay. C, exactly, square root C, indeed. So this was indeed the correct answer. It's in the square root. So surprisingly, it's not hyperbolic. It's not an asymptote. An asymptote, it's the square root. All right. So the rule is every time you get one wrong, you sit, and then at the end we'll have a single winner. All right. Why is the standard inverted index called inverted? Is it because it is always drawn topsy-turvy by convention? Is it because it maps terms to lists of documents, whereas the natural storage of a collection is mapping from documents to terms? Is it because documents are sorted in inverted order of term frequencies, or nobody knows? So even if you're seated, you can continue to answer, right? So it's totally fine. You can continue to participate in the questions. Almost. Let's cap at 1 minute. Are you ready to answer? Okay, I'm waiting for 30. If there is a 30, is there a 30? No 30? Oh, 31. Okay, very good. So B, yes. Oh, you all agree. Very nice. Indeed, that's the reason. And in fact, every index in databases could be considered inverted in this way. We have a comment in the chat. The screen is not updated online. Oh, really? Really? What do you see on the screen? Do you see the question, why is the standard inverted index? Oh, the last question, really? Let me try to see if I stop the sharing and share again. Let's see. Share. Otherwise, we can probably rely on the Clicker app, because you should see the question in the Clicker app. But still, it would be nice if we can actually. Yeah. Is it better? Can you see now? You saw the new question? Oh, okay. It might be specific to a single machine. Yeah. All right. Let me know if the problem continues. Right. Okay, you got it all right. This is amazing, amazing. What information retrieval technique is most adequate for evaluating this query, summer and not June or sun? Language models, Boolean retrieval, ranked retrieval, probabilistic information retrieval. And starting with easy questions, right? The 8, 31. Okay, are you ready? Okay, go ahead. B, Boolean retrieval. Yes, exactly. And, not, or. This is all Boolean retrieval, set of words. Okay. What is the most accurate definition of a type? Is it an equivalence class of tokens? If two tokens appear in related documents, the associated posting will appear only once for each term. Is it the resulting set of a query expansion used to query the index? Is it an equivalence class of documents, which induces an equivalence class on tokens as well called postings? Or is it an equivalence class of words? Types are associated with postings lists in the standard inverted index. If something doesn't make sense, then that's an incorrect answer, of course. This one needs more time to process. 21. Let me cap at 1:20, 1 minute 20. So you have 10 more seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. D, yes, the last one. An equivalence class of words. Types are associated with postings lists in the standard inverted index. The others, they just don't make any sense. Query expansion, that's not an equivalence class, it's asymmetric. Equivalence class of documents, no, this is all made up. And the first one, if two tokens appear in related documents, all of that is just blah, blah, that doesn't make sense. Yeah, okay. Okay, what is the Dewey decimal classification? Is it the core algorithm used by Google to index the web? Is it a number-based system used by many libraries in the world to sort and retrieve their books? Is it a standard used by mathematicians to classify sets? This one we already had, I think, during the lecture. Right, I'm capping at 1 minute. 15, 14, 13, 12, 11, 10, 5, 4, 3, 2, 1, and 0. B, oh, wow, you all get it right. Yes, exactly. This is what's popular in libraries. Yeah. When I was a kid, this is how we actually had to get the books, right? We didn't have, well, we did have computers. I mean, we could type on a computer and that would work too. We had some basic indexing software. All right, which query returns documents 5 and 8? So this is in this incidence matrix. I want 5 and 8. One of these queries returns exactly that. Which one? So I'm going to show the matrix on screen. Twenty seconds. 15. 10, 9, 8, 7, 6, 5, 4, 3. Are you ready? Okay. Yes, exactly. That's U and Y. You see, it's the intersection. U, there's a 1 here and here, and 8, there's a 1 here and here, and that's the only ones where there's a 1 on both, right? So this is indeed correct. Which one of the following is the standard inverted index for this collection? It's a collection of 4 documents with the bag of words model. There is no order, but there are occurrences. And I'm asking for the standard inverted index. Standard inverted index. They are the first 2. These are the other 2. "15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Which one? Yes, exactly. Yes, exactly. So here you need the terms, but 1, 2, 3, 4, these are the documents, right? Document 1, 2, so that cannot be the last 2. And here, exactly, standard means this one. These are integers here, and these are the document IDs. All right. Very good. We have the majority. Why? Very, very good answers today. Why does inexact top K retrieval make sense when we only consider a subset and then evaluate the top K in there, right? Is it because precision is irrelevant to ranked retrieval? Only relevance of documents is, which is why they are ranked? Or is it because it leads to increased precision and increased relevance at the cost of being slower? Happy users come back. Or is it because using cosine computations on vector representations as a similarity measure is already an approximation of reality, so going inexact does not hurt the results so much? Or does it not always make sense? And inexact top K retrieval does not make sense if K is 5, 8, or 13, but it makes especially a lot of sense if it's equal to 10. All right, 5 more seconds. Pick a random one. 3, 2, 1, 0. Yes, exactly. Yep. So indeed, it's already an approximation anyway with the cosines, so it doesn't really hurt to approximate more. The other one, no, it doesn't increase precision. There is no link with that, and precision is not irrelevant to rank retrieval. We saw you can also draw the curves in that way. Yeah. And the fourth one is made up. Okay. Which of the following is a 3-5 B plus tree? Some of them you already had during the lectures. Some of them are new, but some of them you had. So I'm looking for 3-5 B plus trees. Everything is important there. The 3, the 5, the plus. According to the convention in the course, of course, because I explained that there is no standards. All right, 10 more seconds. 9, 8, 7, 5, 4, 3, 2, 1, 0. It's this. Did you say the second one? B, yes, exactly. So the first one, there's actually two reasons why it's incorrect. First, there's a typo with 2 and 22, but even if that were 22, that wouldn't work. Does anybody see why it's not a 3, 5, B plus 3? The root can have less, right? So the root has 5 children between 2 and 5, but look at the leaves. They have 5 keys. 5 keys would mean virtually 6 children, right? So you cannot have 6 children. So the number of keys must be between 2 and 4. So that's why it's the second one. And the second one is fine because the root can have 2 children. All right? Very good. Did you get it right? Okay, awesome. Which one of these ratios did we not define as an evaluation measure? True positives over all returned results, true positives over all relevant documents, true negatives over all non-returned documents, true negatives over all non-relevant documents. One of them we did not define as an evaluation measure. "25 seconds. 20. 15. 10. 5, 4, 3, 2, 1, 0. C, yes, exactly. True negatives over all non-returned documents. The first one is called, everybody at the same time, the first one, precision, right? The second one, recall, and the last one, specificity. Yeah. And the third one actually makes sense. True negatives over all non-returned documents, that's kind of a precision for the non-returned, right? But there is no name for that. If you have ideas, you can send them to us. Maybe we can just make the suggestion to the community, but I'm not aware of any name for that at the moment. All right. How many? Oh, wow, what just happened? Everybody seated? Okay, let's look on Zoom. Let's look on Zoom. Oh, what happened? Since when are you all seated? I didn't pay attention. This question, okay, then everybody stands back up because we need a winner. So when that happens, we just okay, now we can continue. That's the rule, right? If everybody sits, then everybody stands back up. Okay. How do bigram, k-gram, and bi-word or k-word indices differ? First, they don't differ. Second, k-gram indices are indexing on sequences of k characters and are used for phrase search. K-word indices are indices on sequences on k of k-term, and they are used for tolerant retrieval. The third one is the same, but tolerant retrieval and phrase search swapped. And the fourth one is k-gram indices do not exist. K-grams are used only for generating Markov chain-based language models from documents. Right? 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. C, yes, exactly. So tolerant retrieval for the k-grams, k-word indices at phrase search, because you need the order of words. Still have a lot of people still here. Okay, 30 seconds for that one. 30 seconds. What is the correct base formula? Which is the correct one? 10, 9, 8, 7. Oh, wow, you need 20 votes, that's good, okay. 1 and 0. Yes, the first one. You see, when you multiply here, what you multiply with must always match the condition here. That's how you can tell. Then you divide by the other. So here is not the case. So that's inconsistent here. And here that also doesn't make sense. You have to multiply, not divide. And also here that doesn't make sense. All right. Next one. Again, 30 seconds. How do we make precision and recall work on ranked retrieval? First, we can't. It only works on Boolean retrieval as it's based on return sets, not ranks. Second, this can be redefined in the frameworks of inexact top-K retrieval by comparing it with exact top-K retrieval. Or 3, we just adapt precision and recall to weighted scores. Or 4, we go down the results and draw a curve plotting precision against an increasing recall. Okay, let me give you 45 seconds because it seems needed times to read the questions. 10, 9, 5, 4, 3, 2, 1, 0. D, exactly. You remember this curve that we drew going down? Okay. Okay, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 here and 1 on Zoom. 13 people still in the game. Let me, if we don't do them. Okay, here's this one. There are 3 boxes. In box A, there are 2 Luxembourg-Early. In box B, there are 2 Toblerone. And in box C, there is 1 Luxembourg-Early and 1 Toblerone. You pick 1 box at random, you take it home. At home, you pick a candy from that box also at random, and you notice that it is a Luxembourg-Early. What's the probability that the other candy in your box also comes from Sprungli? Meaning Luxembourg-Early, because I think that's not necessarily common knowledge. So what's the probability the other candy is also a Luxembourg-Early? 1/3, 1/2, 2/3, or 1? Okay, let me give you 10 more seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. What do you say? C, 2/3, exactly. Who wants to see a picture? Okay, let me show you one, because I have an explanation for this. Oh, no, that's not the right one. Oh, that's the one I wanted to show. Okay, so these are my 3 boxes. These are Toblerone, Luxembourg-Early. We are looking basically for the probability that it's the 3rd box, right? This is what it means. The other is in Luxembourg. So what's the probability that it's the 3rd box, box C, given that the candy is Luxembourg-Early? Bayes, that's the answer. So if we apply the Bayes formula, we get that its probability of box equals to C, which is 1/3. Probability of the candy being L, given the box is C, that's 1. Given box C, it's always a Luxembourg-Early. And the probability that the candy is a Luxembourg-Early, that's 1/2, right? Because half of the candies are Luxembourg-Early. And that gives us 2/3. But let me show you if you even do it visually. So these are the numbers here. And technically what you do so the prior would be probability box C. So the prior is 1/3. So a priori, it's 1/3 of probability that it's box C. If I add the information that it's a Luxembourg-Early, the first one, then now we have 3 cases left, and 2 of the 3 correspond to box C. So now you see 2/3 visually. Right? For whom does that make sense? Right. So you can either do it visually or you can do it with the Bayes formula. Okay. All right. Let me look for this one that I wanted to say. I'm prioritizing now in case we don't have time. So 1, 2, 3, 4, 5 still standing in the room, and the TAs as well. And in Zoom, 1 as well. So the query is foo bar foo. I'm using language models. So which ones of the following documents would be returned on top following the language model approach with unigrams, with bags of words and no smoothing? Bar 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 bar, bar 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 foo, bar bar foo bar, foo bar foo bar, foo foo bar bar, foo foo bar foo, or foo 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 foo. Yes. Oh, I haven't started. Yes, that's true. Yeah. All right. Foo bar foo. Okay. 10, 9, 8. Oh, I scroll. 7, 6, 5. So this one? Oh, so the TAs are now seated. Okay. 2 of you have survived. And on Zoom, let me see. Wow, so now there are 2 of you still in the race. Okay. So first you can eliminate, right? If you have bar, 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 you build a model for that. It's never going to generate foo, bar, foo, because we don't smooth, right? We don't generate bars. Then you can go to the ones that are the closest, right? So this is basically here. Here, that cannot be the solution because if you don't smooth, it will only generate foo, never bar. So it's between this one and this one. And now you can just fine tune, right? So here it's 1/2. So that would be 1/2 times 1/2 times 1/2. That is 1/8. And here it's 3/4. So that would be 3/4 times 3/4 times 1/4. And you're basically comparing 9/64 with 1/8, right? And 1/8 is 8/64. So 9 wins over 8. Why did I not care about unigrams? Because that would just be a factor of 3. So the number of ways you can permutate permutations of foo bar foo, there's 3 of them. So it's a constant factor, so that in that case doesn't play any role. All right. Okay. So let's try to pick a winner between the 2 of you still in the race. What are your names? Felix and Lucas. Felix and Lucas. All right. So what do I want? This one. Encode the following postings list with the gamma codes. Remember what we do, right? Because the posting list is an increasing list of integers. So there is a specific way we pre-process before encoding. So 1, 4, 5, 8, 10, 15, 16, 20, and I want 1s and 0s. So in that case, I'm going to wait for the 2 of you, right? I'm not going to stop before you have it. So do you have it? Okay. Yeah, I'm waiting. So Lucas has it, and Felix, you have it too. Okay. You have an answer too? It's the second one. Ah, so you stand back up. We don't have a winner yet because both of you are seated now. So you can stand back up, Felix and Lucas. Yeah. So look at what's going on. We encode the gaps. So it's 1 for the first one, then 3, 1, 3, and so on. The encoding for 1 is a 0, right? 101, that's the encoding for 3 in the gamma code. Then 0 is the encoding for 1. Then again, 101, that's 3, and so on and so on. So already by elimination, you could come up with that answer, right? Okay, what can I do? I need maybe a tougher one. Okay. Decodes the following variable byte encoding of a posting list, but bits are grouped in 4. Oh, this one, I can't remember what convention I took with continuation flag. No, wait, no, let's not do this one. I can't remember if I put 1 or 0 with the continuation flag. At the exam, we would tell you. Why do we need term IDs in a sort-based index construction method like BSBI? Why do we need term IDs? Yes? Lucas too? Yeah, all right. What would you have said? See, yes? Okay, then you can stand back up again. Okay, so indeed it takes too much space. That's a compression scheme. Do you think that is a good engine? Yes? Okay. What would you have said? Yes, the second one. Okay, there is some correlation or counterfactual dependence here. Okay, so I guess that you're still in the game then, because both of you also got it. Sorry? In the worst case, yes, if we arrive at the ends, you get 1 each. But if one of you manages to beat the other before the ends, which ones of the following pairs of compression schemes target makes sense? A gamma encoding of posting lists, a gamma coding of dictionaries, a front coding of posting lists, or a front coding of dictionaries? You need to get everything right here. It's a multiple answer. Right? Yes, we're good. Okay. These are the two. You can gamma encode posting list or front code the dictionaries. Okay, still got it right. Sorry? Oh, there are more options? I didn't pay attention. Oh, yes, yes. Did you also get these ones right? Variable byte encoding of posting lists and blocked storage of dictionaries. So it seems that Lucas is the winner. Congratulations. Big applause for Lucas. And this is for you. Congratulations. All right. So I guess that this leaves us with the end of the semester, right? So thank you very much for being such an awesome audience, for participating in the course. I hope you enjoyed it. I hope that you learned a few things in the process. If you're interested in going more into large scales Then you can come back in fall for big data if you are interested, and you will see again this MapReduce things and the log structured merge trees, but then we will focus more on tables and graphs and cubes and trees, so all the other shapes. So thank you very much. Have a great summer. Have a good preparation. We are here for you during the summer, so the TAs and myself. Don't hesitate to ask questions. We can support you in any way. See you soon, at the latest in August. Thank you.